Hello, this is the final showreel video submission for the Advanced Technology module, which has both the portfolio projects. During my first teaching block, I was assigned to the rendering techniques topic as we had to combine shader aspect with game development. An idea sparked to work on a echolocation render effect as it provided a new approach to producing a game mechanic which could be used in first-person game modes. A game example that influenced this concept is called Muffled Warfare, which is a first-person multiplayer game that uses sound to navigate enemy opponents and eliminate them. Recent research and game design shows that echolocation can be gamified to help sighted players understand how blind individuals navigate the world. One study from ACM Digital Library emphasizes involving blind users to create more immersive, audio-focused gameplay, and another article discussing how orcas, the marine mammals, locate their prey using sound. Therefore, it piqued an interest with pursuing this concept by making it a prototype for this portfolio project. Initial work progress began with creating dedicated materials for the level environment and to mimic the impulse effect. First, the directional and skylight were removed from the outliner to make sure that the scene starts off as dark. Then, the environment material instance called mPostProcessAdd acts as a blendable material that applies custom screen-wide visual effects by adding color and visual distortion on top of the final rendered scene environment. The material here is divided into two sections. This part creates the visual by altering the screen's color and depth to make an overlay effect. This part controls how strong the effect appears using color channels and masks for smooth fade in and out. The final nodes converge before the material result node and get plugged into emissive color due to post-processing materials emitting light directly onto the screen and into opacity as it controls the strength of the effect. The second material, called M-Ripple Decal, creates a circular ripple or ring effect that expands outwards and fades over time. It's meant to be used as a visual decal as this logic gets triggered through a sound blueprint which gives the illusion of sonic pulses. The second phase progress started with creating the blueprint BP sound generator that triggers the ripple effect to spawn over the level surface. Construction script sets up the dynamic material instance for the ripple and initializes color, location, and emissive strength before runtime. Update radius function takes in a float value and updates the scalar radius inside the ripple material. The event graph controls the full ripple cycle using timelines and randomization. The top left sets up the ripple material and its properties, while the top right adds slight random offset to the spawn position. Bottom right animates the ripple's growth. Bottom left handles its fade out. For the third and final phase of making this prototype, to make sure the ripple stays consistent with each step, a rigged skeleton to the first-person arm mesh was attached, allowing to track foot movement accurately even in first-person setup. The sound generator blueprint is also called within the projectile blueprint to make sure the ripples spawn depending on the area which gets impacted by the gun's projectile. Once the sound blueprint gets placed on the scene, it sums up to provide a reliable and immersive eco-visualization effect as the player walks through the level, making the regions within the radius of the ripple visible to the player's perspective and vanishing after a few seconds. The topic that was assigned for me during my second teaching block was generating game assets using AI. Here I chose to work with an AI model called Stable Diffusion with creating 2D isometric game assets to create a city/town builder prototype. A game example called Village City, a town building sim, was taken as reference for planning out a similar cozy asset style. Generative AI is changing how game assets are created by enabling developers to quickly produce stylized 2D and 3D visuals. One article from Unity explains how tools like Stable Diffusion can generate consistent concept art and textures. The other one here shares about how 3D models are made in Blender and then are rendered from isometric angles through Stable Diffusion to generate stylized game-ready 2D sprites. Hence, this proved convincing enough to test the potentials of how precise an AI model could produce usable assets for video games. The first step progress was with installing Stable Diffusion's Web UI version, which can be found in a public Git repo on the internet. Then, the application itself was opened through a batch file within the downloaded folder, essentially resulting in a web page view of the AI model. The building structures were modeled in Blender and rendered from an orthographic isometric view. Once the structure was done, within the Blender's compositor, the depth data was extracted from the render layer, then normalized and inverted to convert distance into a clear grayscale image, where closer areas appear lighter and distant ones essentially darker. This black and white image represents the structure's depth and is then used in Stable Diffusion's ControlNet extension to generate stylized 2D assets while maintaining the model's shape and perspective. Now, the second stage progress was to work with the AI model itself to produce desirable 2D asset outputs. ControlNet acts as an extension to Stable Diffusion that guides the image generation using input data, in this case, a depth map. It helps preserve the structure and perspective of the 3D model while generating a stylized 2D version. This ensures the output stays accurate to the original geometry. After giving in the do's and don'ts, building specific instructions under prompt and negative prompt, options like sampling steps, sampling method, batch count, and CFG were tweaked as they control quality, style of image generation, and how strictly the AI follows the prompt and how many images are produced at once. It finally produces 4 images as instructed, which then in this case is game ready to be used within the builder prototype. The third progression phase involved with creating the game mechanics for the assets to be used within the city/town builder's prototype game. To allow smooth camera movement across the map, a tweening system was used to animate transitions like panning and zooming without sharp jumps. This makes the camera feel more natural and fluid when navigating the map. The prototype has 3 main systems that define it as a city and town builder game. Economy. This tracks the money your city makes. Each new building you place affects its resources. Happiness. This measures how well the city is functioning. Building homes and other infrastructure increases its bar to a default value of 5. Population. Every house you build adds citizens to your city. This also increases its bar to a default value of 5. All 3 systems are visually shown with the bars and update dynamically as the city grows. They're powered by individual scripts and managed through a shared script called the Resource Manager, which keeps everything in sync. Players can place buildings and roads across a grid, with the interface reflecting changes in the economy, happiness, and population through the very simple visual indicators. The game works as intended, mimicking core mechanics found in builder games, where each building placement dynamically affects resource values, offering foundational simulation of city growth driven entirely by AI-generated art. These are some of the current limitations and drawbacks I encountered while working on both projects. However, each of these issues has room for improvement and could be resolved with further development. Thanks for watching.